Industrial automation systems run 24 hours a day, 7 days a week, executing millions of precise actions without failure. In modern facilities, the nerve center for this continuous operation is overwhelmingly ignition by inductive automation. It is the definitive SCADA platform, trusted by 69% of the Fortune 100. Ignition earned that footprint by eliminating restrictive budget constraints. They introduced an unlimited tag licensing model, allowing plants to pull in massive data volumes. To handle that influx, the 8.3-core Historian, powered by QuestDB, ingests up to 2 million data points per second. As an infrastructure layer, Ignition executes its primary mandate flawlessly. It captures, stores, and visualizes industrial telemetry on a massive scale. The friction in modern industrial environments is no longer about capturing data. The friction lies entirely in how human beings query that massive database to extract specific operational answers. Consider a night shift operation. When a complex asset fails at 2 in the morning, the situation requires immediate troubleshooting. The operator responding to the failure needs a direct answer to a specific question. What happened on line 3 last night? They cannot simply ask the SCADA system that question. Extracting that answer requires navigating pre-configured designer views or knowing the exact obscure tag naming conventions for those specific valves. This exposes the strict boundary between a database and an application. Ignition provides the infrastructure, but there is an application gap between the data it stores and the operator attempting to query it in plain English. Bridging that gap requires a dedicated AI application layer. For facilities running Ignition in 2026, there are 2 highly divergent architectural paths to build that intelligence layer. Selecting the wrong architectural approach leads to months of stalled engineering, depleted budgets, and frontline operators who remain entirely disconnected from the telemetry they need. The first path relies on Ignition's native Aeon roadmap. In early 2026, Inductive Automation introduced the Model Context Protocol, or MCP module, into early access. There is a common misconception that installing an AI module onto a SCADA server instantly generates a conversational assistant. It does not. The MCP module is specifically designed to expose system capabilities via Ignition's scripting engine to external AI systems. It is a developer integration standard, providing plumbing for data, but ships completely devoid of any user interface or natural language capability. Inductive Automation built the MCP module to make Ignition the foundation for developers to construct custom AI-connected industrial applications. Relying solely on this native integration standard provides your engineering team with highly capable tools, but the frontline operator still has no way to ask a question. Turning that MCP protocol into a functional tool requires what is known as the system integrator dependency. You must hire an SI to build a custom software application on top of the infrastructure. That system integrator must write custom Python scripts, establish API hooks, and design a bespoke operator interface entirely from scratch. Custom software development dictates the timeline. This path delays operator access by months of billable engineering hours, rather than delivering a capability in days. This introduces a severe constraint. Industrial deployments mandate strict cybersecurity, specifically requiring air-gapped networks. Building a custom AI application frequently requires routing queries to external large language models via API. This introduces a direct cloud dependency, shattering the native air gap of the plant network. Introducing cloud exposure directly contradicts the primary security rationale for selecting a fully on-premises Ignition deployment in the first place. The custom build route leaves organizations in a difficult position, spending massive portions of the engineering budget to construct an interface that ultimately compromises the facility's secure perimeter. The alternative architectural philosophy avoids custom builds entirely. Instead of constructing a new application on an emerging protocol, you deploy a pre-built application over an established standard. Ignition already exposes its tag data natively through an OPC UA server. This universally supported standard requires 0 core configuration changes to access. Valak is a purpose-built agentic AI application that connects directly onto that existing OPC UA infrastructure. Once connected, Valak immediately translates natural language queries into precise database results. It requires no custom system integrator development. Critically, Valak operates with a strictly air-gapped, entirely on-premises inference model. It processes every query locally, meaning 0 cloud connectivity is required. Because it is a deployable product rather than an engineering project, the time-to-value metric shrinks from months of custom development to a matter of weeks. By treating AI as a distinct application layer rather than an infrastructure build, frontline workers gain immediate access to plant data while preserving the absolute security of the internal network. Evaluating these paths requires understanding that Valak is not a replacement for Ignition. It is a decision about how to properly layer the industrial software stack. System architects evaluating their deployment roadmap for 2026 must choose between these two approaches based on their specific operational reality. The native MCP route is appropriate for organizations with massive engineering budgets, a desire to auto-generate developer views within Ignition, and the capacity to manage long-term system integrator engagements. The Valak application route is designed for plants with an urgent need to give frontline operators data access, a zero-tolerance policy for cloud exposure, and a requirement to leave their existing Ignition configuration completely untouched. If the primary beneficiary of the AI deployment is the night shift operator attempting to diagnose a failure, and not the backend developer writing scripts, a custom build misses the mark. A software platform's long-term product roadmap offers no utility to an operator who needs a critical answer about plant telemetry right now. Ignition remains the premier foundation of modern industrial environments. It excels at collecting and storing the massive volumes of data required to run a plant. But true industrial AI must match the rigor of the SCADA platform it sits on. It must maintain lossless telemetry and preserve absolute network isolation. The optimal architecture divides the labor. The database infrastructure collects the truth, but the application layer allows your people to actually speak to it. Stop waiting for a developer tool to become a user interface, and start layering intelligence directly onto the SCADA system you already own.